So so far, most of the classes that we covered, or all the classes or all the discussions that we covered for cryptography, we were talking about confidentiality, سرية, you're trying to hide and protect and encrypt something بحيث no one has access to it. Cryptography له استخدامات كثيرة beyond confidentiality. One يعني we'll talk about a couple of them في الكلاس هذا. مثلا أحد الأشياء is data integrity. بمعنى أنت تبغى إنه if something have been changed, you know and detect that it has been changed, and there is no intentional or accidental errors that happened. Data origin authentication, أنت تبغى تعرف إنه إذا المعلومة جتك من a certain user, إنه it actually came from that user and not someone else. So you authenticate the message and the source of the message. Non-repudiation is another برضو security property that sometimes want. إنه if someone sends you something, ما يقدر ينكر أو he denies this later on. يعني يقول لا أنا ما أرسلت لك مو أنا, someone else, and all that stuff. So you could use cryptography to actually ensure any of those things. So one of the most common components in cryptography are hash functions. And hash functions, يمكنكم درستوها ومرت عليكم في أشياء كثيرة. It's always like it has multiple uses in computing بشكل عام. Could be a strong one-way function. We will see later how it can be used to store and save passwords. It could give a weak notion of data integrity. ولما أقصد بمعنى weak, بمعنى it doesn't actually guarantee integrity بالنسبة لك unless you're dealing with accidental integrity problems. But say that someone wants to manipulate data, hash functions doesn't protect against this. It is a component to many other things, including digital signatures اللي بنمر عليها. وبرضه it's always a nice source of pseudo randomness. بمعنى إذا أنت تبغى numbers that look like random, yeah, you could use them and then use a hash function to basically create outputs or pseudo random numbers out of this. الhash functions has three main components. الكومبوننت الأولى, it does not have a key. Right? So a hash function is always, you just give it the input and then you give it the output. It has two practical properties and three security properties اللي بنمر عليها. The two practical properties are the following. الأولى إنه it condenses arbitrarily long input into a fixed length of output. بمعنى you could give a hash function a 1 byte or a 1 terabyte, it will always give you the same output length. And to go, this hash function, for example, is a 512 bit hash function. معناها always the output is 512. If it's a 128, always it's 128. But it takes whatever input, regardless of the size, and will always produce the same length of output. The other practical property of a hash function is it's easy to compute. بمعنى it doesn't take exponential time. يعني if you give it a terabyte, it takes a longer time, but not exponentially longer. It's always a linear growth with the size. بمعنى it is always computable no matter how the size is. لأنه it is not an exponential function in computation. It is simply a polynomial function. and it should be faster than encryption. And most of the time it is, and all the current practical hash functions are faster than encryption. Security properties are the following three. This is their description, but let's take a picture. This picture gives you a better description of those properties. So property number one, it is called pre-image resistance. بمعنى إذا أنت عندك h of x, you cannot get back x. If you have the hash of the input, which is x, you actually cannot you cannot reverse this and get the output. The second one is a second pre-image resistance, which says the following. Enter you have x and you have h of x. It should not be computationally feasible to find y where h of y equals h of x. فإذا عندك something and it's hash, you should not be able to find another thing that has the same hash. Hello? The collision resistance, it says it should be infeasible to find any two things, any x and y, and then the hash of x equals the hash of y. الفرق بين هذه وهذه إنه هنا أنت you have x and the hash of x, and you're looking for y that has the same hash. هنا أنا ما أحدك بأي شيء. You could find any x and any y, and they have the same hash. And if you find this, it should be computationally infeasible to find this unless you do a brute force, and we'll talk about the brute force size in the next couple of slides. But this is basically a description. Giving x, it's easy to compute x, but giving h of x, it's hard to determine x. And then you go through the same descriptions here. طيب, we'll go through examples why each one of those are important security features of a hash function. Pre-image resistance. ليش؟ لأنه احنا أحيانا we use the hash to save passwords, and we will talk in some later classes how do we fundamentally use this in a real world example. فإحنا we have in real life that sometimes أنت عندك user I وعندك his password, and basically this is what happens. You know, this is simplistic way, but you know, basically very similar to what happens in real life. أنت you save I, but you don't save P. You save the hash of the P. حلو? When the user logs in, أول شيء the user register. فأنت when he register, you do this. You save his username and you save the hash of his password, right? And let's say بعدين user comes later, you go, look, this is my username and this is my password. You take his password, you hash it, and then you see the hash of this password, does it equal the stored hash? Hello? And if it does, perfect. Means the password is correct. And if it doesn't, معناها the password is wrong. I don't need to know what is inside here to be able to judge whether this password is correct or not. But if I don't have pre-image resistance, أي واحد يقدر ياخذ h of p and reverse it and get p. But pre-image resistance give us the protection that if you have h of something, the hash of something, you cannot reverse it. The second property is the second pre-image resistance, which we see in many cases is used in files. لما خاصة أنت لما you look at open source files. Open source files, you go look, this is the file, and this is the مثلا the MD5 of the file, or the SHA-1, or the SHA-256, or the SHA-512 of the file. So why do they put this? Well, they put this لأنك أنت you could download this file and then compute the hash in your machine. بعدين you compare, you go to the website, you copy the hash they said, and you put it here, and then you compare. And then you see, oh, perfect. If it's verified, معناها this file that I downloaded have not been modified in any way. So if the hash function doesn't give me pre-image resistance, an attacker can take this file ويبدأ يعدل عليه أشياء بسيطة. يعني changes this bit, inject some code, do this, do that. And if he has a way that to change this to a new file and add a piece of malware to it, right? If he has a way to find a hash where it matches the hash of the original file, it breaks the pre-image resistance, the second pre-image resistance, and it breaks the security that I wanted to protect against the integrity and someone manipulating the file. The third example that I need collision resistance is the following. اليوم خلينا نفترض عندنا system, and this system is a bidding system. And بكل بساطة this bidding system ما أحد يثق في الثاني. حراج وتجي مو بحراج، لا مناقصة. Right? It's a bid. أنت تجي وتحط سعرك. حلو؟ فما حد يثق في الثاني، يقول لك يا أخي أنا ماني معطيك سعري لأنك أنت ممكن تعلم سعري الناس الثانيين، والناس الثانيين يحطون سعر أرخص من سعري whatever وكذا وكذا وكذا. فإحنا we will do the following system. السيستم يقول put your price, okay, and then hash it. Okay, let's say within $100, and then share it with everyone else. Okay. فخلنا نفترض في اثنين. أليس قالت أنا بشتري I will do this project for $100, وبوب said I'll do this project for $200. And some الواحد في السيستم حط الموضوع هذا, he's looking for the cheapest price. حلو? So Alice and Bob, they don't share this, they actually just share H1 and H2. Share it in the system يطلع لي بالشكل هذا. fine. طيب اوكي جاء الوقت يلا كل واحد يثبت او كل واحد يقول what did he choose as the value. فAlice comes and say, oh, I chose $100. يجي باب يقول خلني اتاكد, يجي everyone يتاكد, ياخذ $100, hash it again. If it equals H1, والله صادق يا Alice. Perfect. Bob يقول $200. If Bob, لو باب شاف Alice هنا $100 يبغى يغيرها, يبغى يقول I'll do it for $99, يعني dollar less than Alice. If we hash this, right, it will not give us H2. It will give us something completely different. So why do we need collision resistance? Let's say that Alice is super smart. فAlice تيجي تقول I'll do the following. I will find two documents. حط الدوكيمنت الأول, document الثاني. هنا I will put $100. وهنا I'll put $200. ليش؟ لأني أنا إذا everyone like إذا باب حط 200, أنا لو أحطه $199 أنا الربحان as Alice. Here I'm losing $100. I will put 2 files or 3 files. وش بسوي؟ ببدا اغير في الفايلز هذه، اجي النقطه، بغير الحجم، بغير السايز، بغير الانكودينج، وببدا بغير في الفايل هذا وفي الفايل هذا. و every time I will hash them both and I will find any two files بشرط انه في واحد فيه 100 وفي واحد فيه 200، واغير فيهم واعدل واسوي كل شيء until I find this file and this file where their hash is the same. And then I will send this hash. وبعدين بستنى. If Bob مثلا قال أنا I'll do it for 250، أنا بستنى. الحين الدور ما يفرق. المفروض إنه the system, the reason that we use this system عشان ما حد يقول للثاني ابدأ أنت ويبدأ يغير رأيه. Right? We know إنه you cannot change your opinion, because if you change, the hash is not going to work. Alice sends this nice hash and waits. Oh no, Bob, انت اول انت كذا, you know, whatever, it doesn't matter. وكذا. Then Bob says it's 250. Alice has two hashes, a hash of 100 and a hash of 200. When she sees Bob's 250, يقول لك ترى أنا I said 200 and here is the proof. Like, go and hash it, it will give you this. But if Bob said 150, Alice will say, oh no, I said 100. And because the hash of this file and this file are the same, Alice can cheat in the system. And then what happens, you know, if she cheats, it basically breaks the system. This is why we need each one of those components. We need pre-image resistance, we need second pre-image resistance, and we need collision resistance. So, and this is like just giving more explanation, right? That this is another example, someone owes something, some money وكذا. طيب, حنا قلنا إنه by definition, hash functions takes any length, takes any length of data and condense it in a fixed length. فطبيعي لازم يصير في collision. فذلك حنا هنا لما نتكلم لاحظوا ما نقول we want no collision, we want collision resistance. لكن collisions are going to happen. لأنك أنت دائما, يعني تخيل, this is just a simplistic example. We say we have all of those dots, like 15 dots. We are going to put them in 5 bins. We must at some point, if we want to put all of those dots on those bins, we must have some bins that has 2 dots or 3 dots. It must happen. لأنه there is no way, it's impossible to do that hashing without collision. What we want is collision resistance. بس السؤال المهم نبغى نعرف, when does the collision happen? Because this is very important for us. This is what we say, إنه we need to know what is the probability that this collision will happen. يعني أنا اليوم بعد كم كورة أرميها هنا, that collision will start to happen. هل بعد ما أرمي كورة واحدة? And I want to say like collision will happen by more than 50%. لأنه 50% is a random chance, أنا أجي أقول خلاص أنا ما عندي مشكلة, random chance, I'll take it. If it starts to become more than 50%, I get concerned. وش احتمالية إنه الكورة هذه الاحتمالية تزيد على 50% that already في كورة exists هنا. And this is basically what is called the birthday attack. Simply, the solution to this is after throwing square root جذر التربيعي للنمber of possible outputs. هنا عندي 5 possible outputs which هذا بيعطيني 2 point something يعني 2 point something. حلو. بعد this number of balls being thrown in, there is more than 50% chance that there will be a collision. فهنا بعد ما أرمي الكرة الأولى والكرة الثانية، رمية الكرة الثالثة في احتمالية أكثر من 50% that there will be a collision. if we take this ونقول أنا عندي let's say مثلا an output that is 128 bits long. بمعنى أنا عندي 2 to the 128 different outcomes لأنه كل bit could be a 1 or a 0. عندي 2 to the 128 different boxes. If I take the square root of this, وإحنا نعرف square root is very simply إذا صار عندك أس تأخذ الأس تقسم على 2. فafter throwing 2 to the 64 different outputs بعد ما تمر على all of this number of possible outputs بعد ما تطلع الالجوريثم all of 2 to the 64 number of possible outputs الاحتمالية للoutput اللي بعد هذا انه يكون already الالجوريثم put it out أكثر من 50%. So this is basically what we say. إنه 128 bit output will require 2 to the 64 different hashes to conduct a birthday attack. So معناها a SHA-256 will give me 128 different outputs. فتساوي في قوتها 128 different keys. A SHA-384 will give me 192 different outputs, which تساوي في قوتها 192 bit key AS. A SHA-512 will give me a 256 different output, which is equivalent to having AS of 256. So always you divide this by half, but actually you're taking the square root of the number of possible outcomes. فاليوم we have a number of practical hash functions موجودة. MD5 very old 128 bits, which gives me 64 different possible outputs. It is considered to be insecure. SHA-1 is 160 bits. It has been widely used in TLS, SSL, PGP, SSH, S-MINE, IPsec, and many other algorithms, but it is right now considered to be insecure. SHA-2 is considered to be secure right now. SHA-3 is considered to be the standard right now and the best standard that exists out there. I will stop there and continue, inshallah, the discussions and the presentations during next class, inshallah.